Okay. Now I am going to start our lecture with number. This is very basic lecture. You think you know what is number? Can you explain what is number? What is the difference between number and digit? Like English alphabet has 26 letters. Mathematics is also a language, so mathematics has 10 digits. Like English has 26 letters, mathematics has 10 digits. And by using the 10 digits, we can form infinite numbers. As in English, you find there are only 50 lakh words by using 26 letters. But in mathematics, we using just 10 digits and form a huge number, means infinite number. You know what is the process of number. So we can say that number is not easy thing or not a simple thing. So this start from complex number. This is very important diagram, and after making this diagram, we will study one by one, number one by one from rational number, not from natural number, because I think natural number, whole number, integer. Everyone should know about natural number, whole number and integer. So complex number is made up of two parts. The first part is real number, and the second part is imaginary number. We will generally denote complex number with J, and we will denote imaginary number with anything I, sometime I, but there is not no any particular identification of imaginary number. We generally use iota here, okay? And real number is denoted by R. Clear? Real number is formed by two numbers. The first is rational and the second one is irrational. Rational number denoted by Q and irrational number denoted by QC. Okay, but we are going to start our discussion with rational number, since we already know what is integer, natural and whole number. So the first number here is rational number. You have already drawn this diagram in our previous classes, so no need to draw in other times. So rational number. What is rational number? You have any idea about rational number? Number form of P by Q, where P and Q are integer and Q is not equal to 0. And Q is not equal to 0. But what is the meaning of this P by Q? Since in competitive examination, the main is the conceptual part. This meaning means if you say 4 divided by 2, it means 4 by 2. It simply gives 2. But if you say 5 divided by 2, it means 5 by 2, and it does not give a particular result. So this number is considered as the rational number. Any doubt here? So rational number is nothing but a part of division. It's a part of it is a denotation of the division which is not exactly divided. Means 5 is not exactly divided by 2. So we write it as 5 by 2. Clear?
So, if there is 2 divided by 2, that will be rational.
2 divided by? No. We will not define irrational right now. So the definition of irrational number is little bit complicated. I will go in just few seconds. Okay, we are clear. But you find that any rational number, when we change any rational number in decimal, there are two types of decimal. If we see 5 by 2, it gives the result 2.5. But if we see 7 by 3, it gives the result 2.333 dot dot dot. It means 2.3 bar. What is the meaning of 2.3 bar? Means 3 is repeated. So there are two type of number. The first is terminating. This number is known as terminating decimal, because it stops after the decimal point. And the second number is repeating decimal. Is it clear? Any doubt here? No. Means you think that any rational number can be expressed in the form of terminating or in repeating. Okay. But what about the number which is neither terminating nor repeating? Any number, imagine that number that is not terminating and not repeating. So what about the number? Since there is no place of that number in rational number, so we consider that number is as irrational number. And basically, if we find value of root 2, root 3 means imperfect square, that is not a perfect square. Root 5, root 7, root 8, etc. These numbers are not terminating and not repeating. If we find the value of root 2, root 3, root 5, root 7, root 8, root 11, root 12, any number which is not a perfect square, the value of that number always comes neither terminating nor repeating. So these numbers are considered as irrational number. Except from that, pi. Pi is also an irrational number because there is no, pi is not a number which is terminating or neither repeating. So it also comes in irrational number. And if you want to take any arbitrary irrational number, then it is also okay. 7, 3, 5, 4, 7, 2, dot, dot, dot. It is neither terminating nor repeating. Since here I can state neither terminating nor repeating. It is also an irrational number. So what is basically difference between rational and irrational number? Rational number can be expressed in the form of terminating decimal and repeating decimal, but irrational number does not. From natural to rational number, if we see from natural to rational number, every number is subordinate. Means every natural number is a whole number, every whole number is an integer, every integer is a rational number. But if you see the irrational number and rational number, they are friends, not subordinate. Means any rational number is not a irrational number, or any irrational number is not a rational number. So they make a line. They make a beautiful line. They make a line, clear? They make a straight line, and in this straight line there are some rational number between them and there are some irrational number also. So the combination of rational and irrational is called real number. So this line consists real number because this line is nothing but the combination of rational number and irrational number. Here there is infinite rational and here there is infinite irrational number. And this line is known as real number line. Real number line. Clear? Understood? What is the meaning of this number? But there is I can say there is a very there is abundant rational and irrational number, but there is a quality of rational and irrational number. There is a special quality. What is the quality? That if we do a square of any rational number and irrational number, it always gives the value in positive. If we are squaring any rational number or if we are squaring any irrational number, it always gives a positive value. Like root 2, if we square root 2, it gives the value 2. If we square root 5, it gives the value 5. You know that? Squaring, you know that? Just simply squaring means multiply double. Okay? And if you 2 square, it also gives 4. Or 2.2 square, it also gives the positive square. So there is a quality, there is a special quality of these numbers, that squaring of any rational number or irrational number always gives a positive value. So it creates a definition of real number. What is the definition of real number? Any number whose square is always a positive number, that is known as real number. Clear? So we start from rational number. We understood irrational number and we understood what is real number. The real number is combination of sometimes you study or you read in any book that real number is something that is combination of rational and irrational. But the actual definition of real number is what? Any number whose square is always positive. But this quality always followed by rational number and irrational number. Is it clear or not? So there are some property, and you should write it down. You should write it down. Means when I write property of this number, you should write it down. Okay. There are very big properties of numbers, and you should know about that, because in question it is asked. Closure property, the first property is closure property. So we start writing property with rational number. Okay. So what is the meaning of closure property? You know the set. You know the set. Simply, means we have already defined what is set. Means you assume that this is a set, and if you add two things, the answer should be in the set. Means if there is a set, or if there is a row, means if you have to add two things, means 2 plus 4, it gives 6. It also belongs to any set. This property is known as closure property. Means if we talk about closure property of rational number, means if a plus b, that is equals to, if a is rational, and b is also rational, then c must be a rational. Understood? This is known as closure property. Means if you add two numbers, the third number belongs to the same group. Okay. If it belongs to subtraction, subtraction means a minus b is equals to, it belongs to subtraction. Yes, because if you subtract two rational number, it always gives a value of rational number. It belongs to a rational number. So addition and subtraction. In addition and subtraction, closure property followed by rational number. In addition also, in subtraction also. Understood? What is the point? This is known as closure property. This is the addition of closure property. This is the subtraction of closure property. But the question is in natural number, closure property followed? In natural number, means if you add two natural number, it always gives a natural number. Is it right or not? If you talk about add, is it right? Means if you add 2 plus 4, it gives 6. It always belongs to a natural number. Means any natural number when added always gives a value of natural number. So in natural number, this closure property follows. But in subtraction, the property is not followed. Why? If you subtract 2 minus 4, it gives value minus 2, and minus 2 does not belong to rational number. Sorry, natural number. Clear? So we can say that in natural number, closure property is only followed by the addition of number. So from integer, we have to be very conscious about addition and subtraction. But after, means from rational number, we have to along plus, minus, multiplication, division. Okay. Now the second property, commutative property, very important property. And I will ask you a question after this property. Commutative property. A plus B is equals to B plus A. This is called commutative property. Means if you add two numbers in any order, it will same. Okay. A plus B is equals to B plus A. Example, 4 plus 5 is equals to 5 plus 4, that is 9. This is known as commutative property. Then I will ask a question. Then tell me, this is a very lowest property that I know. If we add two numbers in any order, it will always same. So what is important to find this property? This is not necessarily property, because if you add any two number, in natural number also, in whole number also, in integer also, in rational number also, in irrational number also, this property is followed. But what is need of this? This is a need due to that complex number. In complex number, the whole system will change. Not completely change, but the whole system will little bit change because there is something another. So this property seems very easy, but when you talk about complex number, it seems you face some difficulty. Okay, now we understand these two property. So write it down. In front, in upward, you should write rational number property. After that, we will discuss the property of real number. Now we will discuss about third property, that is associative property. Associative property, associated law means there are three numbers A, B, C. If we add A plus B, then after C it is equals to A plus B plus C. Means we can add in any manner. We can add A, B first and then C, or we can add B, C first and then A. The result will be same. Means we can in subtraction, in multiplication also it will be same. Means A multiply B multiply C and A multiply B multiply C. In commutative property also, A plus B is equals to B plus A and A multiply B is equals to B multiply A. Clear? In addition and multiplication, everything will be same. Now the fourth property is additive identity. Additive identity means what? The number when added does not change the value of that number. Means if we add any number with 0, it will change the number? No. Yeah, 0 plus A, it always remains the same number. Means 0 is known as the additive identity because 0 does not change the value of that number. Clear? And what about multiplicative identity? Multiplicative identity, A multiply 1, if we multiply with 1, the value will never change, or 1 multiply A, it gives the result. Clear? Now what? Inverse, additive inverse. Inverse means opposite of identity, means if we add that number, the value will collapse. So what is the number? A plus minus A. It gives the value 0. Or we can say minus A plus A. It gives the value 0. Example. If we add 5 with minus 5. If we add 5 with minus 5. The value is 0. Then we can say that minus 5 collapse the identity of 5. So minus 5 is considered as the additive inverse. So here minus A is considered as the additive inverse. How can they ask the question? How can they ask from these? These are the law. They cannot ask directly question from that law. But they ask in examination that this is the additive inverse of that number, or you have to apply additive inverse of that number with that operation. Then if you don't know about what is additive inverse of any number, you will confuse. Clear? Now multiplicative inverse. What is multiplicative inverse? If you have idea, then tell me. Any idea? A 1 by A. 1 by A means if A cancel, it gives the value 1. So minus A is known as additive inverse, and 1 by A is known as multiplicative inverse. Clear? So if you want to find additive inverse of 5, it will become just simply minus 5. If you want to additive inverse of minus 7, it becomes 7. Just opposite. You have to use plus sign or minus sign. If you want to find additive inverse of minus 8, it becomes 8. Okay. And if you want to find multiplicative inverse of 5, 1 by 5. And if anyone say that you have to find 7 by 5, multiplicative inverse of 7 by 5, you have to interchange it, 5 by 7. Clear? This is the basic theory, but you have to know the technical word also, because in question, if you see the questions, previous question, there are more technical word that is used, especially in set relation function. Clear? Okay, write it down. You have cleared from okay. Now the last law, and that is very important law, that is used, that we generally use but don't know the technicality of that one. That is distributive law. Distributive law say A multiply B plus C, it gives the result AB plus AC. This is distributive law, because if we add B plus C, instead of add B plus C, we can also do A multiply B and A multiply C and then add. Okay. We can it is also sometimes written as B plus C times A. Both are same. And here A B minus C is equals to AB minus AC. Clear? This is known as distributive law. So by the use of distributive law, we generally do these things. If there is a question A plus 4 and 5 minus B, how can we do this? A to 5 minus B. So we just do A to 5 minus B, or 4 plus 4 to 5 minus B. This is distributive law. by the help of distributor we can do this question, but actually we don't know. It is okay. So 5a minus ab plus 20 minus 4b. This is the result. 5a and that is it. Okay, understood? This is distributor, and now okay, you should write this, and after that we will go on real number. Done. Now these all property are also followed by real number. Which property? Closure property, commutative property, associative property, additive identity, multiplicative identity, additive inverse, multiplicative inverse, and distributive law. These all property are also followed by real number. So we understood the real number and the property of real number. Okay, now we are going to study complex number, because we have already introduced the imaginary number. So you have a basic idea about what is imaginary number in our previous classes. So if we talk about complex number, so here there are two things we studied that. The first thing is real number and second thing is imaginary number. We understood the real number property. So let us assume that this is real number. A square of any positive number is positive. Okay. Now we have already introduced root over minus 1 in our previous classes. That a square of this number become negative. So it comes under imaginary number. Any number whose square become negative is come under. So how can we define it as minus 4? Minus 4 is written as 4 multiply root over minus 1. Can we write it as? Then it becomes root over 2 and root over minus 1. Clear? This root over minus 1 is known as iota. Since we have already discussed this topic, but we can we briefly discuss about it so that you become familiar. This minus 1 is known as iota. Iota is a Greek word. So we know about what is mean of iota. So there is a table. Iota is equals to root over minus 1. Okay. Iota square, it is equals to minus 1. Iota cube, it becomes, what is iota cube? Iota square multiply iota. Then it becomes minus 1 multiply iota. Then it becomes minus iota. Okay. And iota to the power 4, iota square. Then minus 1 multiply minus 1, it becomes plus 1. Clear? This is a table. We know about it. Okay. Then what is the image? What is root over minus 1 indicate? Root over minus 1 indicate this y-axis. Real number indicate this axis, x-axis, and this y-axis, vertical axis, is represented by iota. Clear? So if we say, we can say it as real number line. What we can say? Imaginary number line. And what is the speciality of imaginary number line? Root over minus a is always attached with that. So if there is a 5 and there is a 7, let us assume, or 8, 9, 6. Okay, here 5 can be written as 5 because there is no speciality here, no special feature here. But here if you want to write 7, you have to attach iota. You have to attach -1 means iota. So here here 7 is represented by 7 iota. It means it lies in the y-axis. Clear? So any point in a space, let us assume this is a point in a space P, is represented by 2 points, x-axis and y-axis. This x-axis is 5 and y-axis is 7. Okay, this point can be written as, this 5, 7 can be written as 5 in real part and 7 in imaginary part. So we write it as 7 iota. Clear? So what is the mean of this thing? This mean generally a point in a plane. This is not for addition. This is for denotation of any point. This part indicate real and this part indicate imaginary. Imaginary part indicated by iota. So this number, this point is known as complex number. Clear? So we denote complex number Z is equals to A plus iota B. Understood this concept? Where iota comes from? Where this A plus iota B comes from? Many students does not understand this thing and they want to solve question. But it is impossible to solve any question without knowing this. Okay? What is A? A is the real part. What is B? B is imaginary part, y-axis. So we have to denote it with iota. Understood? Now Z is equal to A plus iota B. And this means the representation of a complex number. So complex number, what is the meaning of complex number? Complex number nothing but a points in plane. Okay, I will give you time to write down. First understand understand it very clearly. Okay, if you have any doubt, then ask me. This is going to be the foundation of our examination. Clear? So there are two systems to represent this complex number. The first system is general form and the second system is polar form. There are many names of this: trigonometric form, polar form, but we generally consider it as polar form. Okay, general form we represent it as A plus iota B, as you did it here. And in this form, in polar form, how can you represent it? Let us assume this is a number. Okay, this is a point P, 5 and 7. Now the distance of that point from origin, let us assume with R, and the angle with x-axis represent with theta. Then we can write this as Z is equals to P is equals to R theta. This is a representation of a complex number in polar form. Polar form means in the graph form. What is the mean here? R means the distance from origin, and theta means the angle with x-axis. I can write it. R means distance from origin, and theta means angle with x-axis. Okay. Now this R distance is known as magnitude, yeah, modulus of complex number. Understood? What is modulus of complex number? There is a huge question from the modulus of complex number. This R, simply R is known as modulus of complex number, and this theta is known as amplitude of complex number. You have also noticed the amplitude. There is a question, amplitude arguments. It is also known as arguments. So you have always see this term and you will confuse. This is nothing but the value of r modulus and value of theta. Now our task is to connect these both terms. In complex number, we have to connect these both terms so that we get a very short formula to find a complex number in this form as well as this form. So in our complex number theory, we will study about that. But here we will only discuss about, we have to discuss about the introduction part. So I hope we introduce it very clearly. So what is complex number, what is real number, what is imaginary number. After that, we will solve question on the basis of these questions. Okay, then write it down. Write it down as it is written in this book. We have already discussed about relation. Then what is relation? Relation is nothing but a subset of product, Cartesian product. So we can say that R is nothing but a subset of Cartesian product. Is it right? To solve. And R always from A to B. Okay? Clear? So there are three things to find in relation. What is three things? The domain of relation. The second thing is range. And the third thing is codomain. Three things. And we have already discussed about it. The representation, domain, it is domain R, range R, and codomain is at codomain. Clear? What is domain here? The first coordinate. First coordinate means in set A, the whole things is known as first coordinate, and it is called as domain. What is range? Second coordinate. Coordinate means which we connect it, from which we connect. And the third thing about codomain, set B. The whole set B, which is connected or not, is considered as codomain. We will give an example. This is the arrow diagram representation of relation. Suppose 1, 2, 3, 4. One connected with A, B, C, D, E. One connected with A. Two connected with B. Three connected with C. Four connected with D. Now here domain is equals to 1, 2, 3, 4. Okay? Range A, B, C, D. Okay? And codomain, the whole set B, A, B, C, D, E, which is associated with A or not. The whole domain consists is known as codomain. Clear? Any doubt here? No. You should write it in this diagram. You have already written the relation, but I think you don't form this diagram. Form? Okay, then. Then how many types of relation? Then there is a new technical word, relation in a set A. What is the meaning of relation in a set A? It simply means from A to A, means from that set. We can write it as relation in a set A, means R from A to A. Clear? And there are three types of relation. The first type is reflexive. You know about that? You have written or not? Written? Okay. Reflexive. The second is symmetric, and the third is transitive. In reflexive, what is the condition? AA belongs to R, but same term belongs to R. In symmetric, what is the condition? AB belongs to R, imply that BA belongs to R. Clear? And transitive, what is the condition? AB belongs to R and BC belongs to R, imply that AC belongs to R. Clear? Read out here. In previous, means in earlier competitive examination, there is no any question about reflexive, symmetry and transitive, because it is all about provement. But nowadays the question is given that you have to find this is reflexive or not, this is symmetric, this is transitive. Okay, and you have to identify it by provement, but it is an MCQ question. Okay, so we have to understand the provement of this question. How can we prove that it is symmetric, it is reflective, or it is transitive? But by first we complete that whole scenario. After that we will prove one or two questions here, so that we will give a clear idea. And any relation which is reflexive, symmetric, and transitive is an equivalence relation. You know it. Equivalence means if this is reflexive, symmetric, and transitive, then it is known as equivalence relation. Clear? Now the very important thing, equivalence class. Equivalence class. It is denoted by A. It is denoted by A. First understand what is the meaning of equivalence class. Let us take an example. One A. Let us take an example that this is a relation. 1A, 1B, 1C, 2A, 2B, 2C, and we have to find the equivalence class of A. So we have to check that A is connected with whom? A is connected with 1, then it becomes 1. Okay, A is connected with 2, then here it is 2, and A is connected with 3. This is known as equivalence class. Means if you want to find equivalence class of any particular set, you have to check the relation from which it relates, and you have to write the elements of that relation. Okay, this is known as equivalence class. Understood? Then if you want to know that equivalence class of B, what can you write? 1, only 1. B is also belongs to 2. Okay, then here 2. Understood? This is very important, because equivalence class participate or divide each set into a disjoint set. You know a disjoint set, which are not there are no any intersecting point. So this equivalence class divide a set into disjoint set. Means if I say C, correction of C, 1 or 2. Understood? What is equivalence class? If you want to write this, you have to write this, or otherwise you can leave it. But right?